Hi. So yeah, if you've not come to see this or any .NET talks, then perhaps you're in the wrong room. But I'm Pete Gallagher. I'm a freelance consultant from the Midlands, Loughborough to be precise. I run 2 or 3 meetups in Nottingham, so if you've come down to Nottingham, then you may have been to .NET Notts or Notts IoT or Notts Workshop. But similar to what we're doing here tonight, we've got speakers from all over the place coming. In fact, we've got David coming a couple of months' time to do. Is he doing the same talk? I can't remember.
No, I didn't actually say what I'm doing.
Oh, okay. Ranting about your boss. Yeah, that's good. I'm also an MVP like Kev. So we're both crying into each other's beers because that conference has just been cancelled. I don't know if you've seen, because of coronavirus, which I'm guessing is probably the reason why there's no one at the front here almost, and you're all down at the back with your masks on. I'm also a STEM ambassador, so I like talking to children and young adults about the sort of stuff I'm talking about tonight, but mainly just because I'm a big geek and I like toys. So tonight we'll do a basic introduction to IoT, and then I'll talk a bit about the software that's out there, and then, as David pointed out, is it David or Dave, or what do you want? David pointed out, I've got some hardware that I'll show too, and then Q&A afterwards. But what's IoT? I kind of ignore that part at the top, the wide say. I like this one at the bottom, which is basically just a whole heap of connected stuff talking to each other. And we all know things like the Nest thermostat, or the Amazon Alexa, or Philips Hue bulbs, or wearables like this, or perhaps logistics and stuff like that, where we're mapping telemetry all over the country and stuff, which is cool. Or something like this guy, and we'll come back to him in a minute. In fact, I like making little bits and bobs, and Kev's got this thing called a Logitech Spotlight. I don't know if you've ever seen this. It's like a really expensive presenter pointer where you can sort of spotlight a bit on the screen. They're 120 quid normally. They're on special offer at the moment, but normally. So I built one out of 2 microbits. And the reason why I'm telling you that now is because I don't want to have to keep using this, because it's probably going to go wrong at some point and I'll just look silly. But the idea is you can obviously go forwards and backwards with your slides, just like you would normally. But if you shake it, then we get a spotlighted area that you can highlight. Now it's terrible, obviously. It's not as good as a 120 quid device, but it was really just to prove that you can make all sorts of stuff if you put your mind to it, or if you can't afford a spotlight presenter. But I don't want to keep using that because it will go wrong and I will look silly. So I'm just going to stop the code. I'll switch to a real one. And hope that it works. Ah, good. That's all right then. So yeah, a couple of years back, Gartner forecasted there'd be 14.2 billion IoT devices by the end of 2019, and in fact 25 billion by 2021. But if you go on Statista, then they reckon those figures are a lot higher. So, nearly 27 billion by the end of 2019, and nearly 36 by the end of 2021. So it's pretty big. In fact, this is like the hardware element of the IoT landscape, and that fits into this overall picture, and this was from 2018. So that's 2 years ago, and you can only imagine how big that landscape is. So it's huge, and in fact it's missing all sorts of stuff that was around in 2018 even. I noticed there's no particle in that list of hardware. But if you don't want to believe me, you can go and read this 89-page document about what IoT is. I don't recommend you do it. I started looking at it and immediately got bored, and I like IoT. Obviously, it's got a bit of a bad rap, IoT. There's things like fridges that you can strap a whole heap of energy to the front of to stop you from having to open it to let the air out, which just seems completely pointless to me. Is the sound? I didn't ask if there was sound. Should be sound, shouldn't there? You hear that? Quite like it actually. So he opens his ice cooler and he plays that. That's good timing. Opens his food side. It's not very loud, but you can probably just about hear that. So that's dead good. Maybe until you go on holiday to Seattle and your wife gets in touch because now it's stuck playing Ice Ice Baby for yonks, and yeah, she's not particularly happy. So that's fair. Or maybe one of these smart mirrors that just breaks down, or an intelligent coffee mug that you need to sign up for an account for and accept the terms and conditions and then update it before you can have a cup of coffee. Just buy a cup and just use that. Or you can't use your oven until you've accepted the terms and conditions that you may burn yourself when you make garlic bread. Or maybe burn the morning news into your toast, and I can't see what the point of that is either, just look at the news in bed. Having said that, the first IoT device was developed before the first public-facing web page was ever made. So the internet, as we know it, was developed 1 year, and then a couple of years in between that, we got the first public-facing web page, and then we got this in the middle, which was the first internet-connected device. Essentially, he could go onto what was a web browser, and he could tell his toaster to toast. It wouldn't pop the toast down for him, so that was a bit sad, really, but it did work nonetheless. Obviously, with the Internet of Things, we have the internet, and so people are making stuff intelligent, and this sort of stuff's just really scary. I'm not touching anything, so I don't know why it's all doing this. It's good, isn't it? Maybe it's your bulb again.
Should be. Oh, so that's like a dodgy cable somewhere.
Maybe. This is all fine. Hello? Tech. Oh, yeah, and then stuff starts happening when you put intelligence into it, and it spreads, so it's happening everywhere. So it's not your kids you need to worry about when you go out anymore. Your Roomba's getting it on. But for me, IoT is not that sort of stuff, and it's not really the production stuff like Alexas and stuff. It's the STEM side of teaching kids about how technology works through play and physical stuff. So these kids here are learning about angles. I think they've got an Arduino in there that they're able to move a little servo around, which is cool. Or just doing stuff because you can, like I did with my little microbit presenter there. So this guy's hooked a Raspberry Pi and an Arduino up together to an old Xbox wheel and he's moving a robot. Or destroying Where's Wally for the rest of the world. There it is. Cognitive Services rules, man. Or anything that Simone Hetcher does. If you've not seen Simone Hetcher, then please go and see her stuff on YouTube. She's awesome. She makes all sorts of crazy robots. She's done a TED Talk as well. It's worth watching. I've made similar stupid little robots. My kids loved this because they thought it was like a dinosaur or a crocodile, and they'd just put their finger in that little peg at the end and it'd bite it, and that cheered them up. But they were able to get the understanding about how these things were working from that. But obviously, most people want to get into IoT to make money, and there is an industry that's funding all of my fun. So one example is the dairy industry, and these guys here are dairy farmers, and they've got a whole heap of dairy cows sitting in a field, and they need to make more dairy cows somehow. And they don't put a bull in a field anymore and say, go on, have fun. There's a far more technical scientific process that goes on, which involves putting your hand somewhere you don't want to have to put it. But first, before you can do that, you need to figure out when you need to artificially inseminate your cow. Now, a cow goes into heat, it's called estrus, and it's really difficult to try and figure out when a cow is in heat. A really laborious process because it only happens over a certain time. Lasts between 12 and 18 hours, and only once every 3 weeks, and it happens at night. And if you're a farmer, the last thing you want to do after mowing your field all day is stay up all night and watch a bunch of cows. It's not very interesting. Essentially what they do is they sit and watch, and then they can tell just by looking at the cows whether or not they're ready. And if they get that time just right, then 70% of the time they'll get more cows, which is good. Only they're not very good at spotting when they're in heat, about 55%. So when you multiply those two percentages together, you get a new cow 39% of the time. And if you just think the amount of time you've got to sit watching cows, that's not a very good return on your money. So there had to be a way. And I think it was Fujitsu came up with this idea. Let's strap what looks like a tag to our cow, so naughty cows, but it's essentially a pedometer. And then they could track. And this is what the farmers were looking at, is a cow moving around a little bit more. So they track cows. So on a normal day, like a normal mammal, it gets up in the day and wanders around a bit and then goes to bed. You see there at night, it's going to bed, and then in the day again, it gets up and then goes to bed again, which sounds perfectly plausible. On a day when it's in heat, though, with this pedometer, they could see the amount it changes and when it changes. And they plugged these figures into a bit of AI, and they realised that that was the start of estrus. And they could get that start of estrus by about 95% accuracy. So now with your 95% and the 70% conception rate, we get about a 70% increase in pregnancy from cows, which is awesome. They figured out this time here was exactly when they should be inseminating to get the best chance of making new cows. It's about 16 hours, as it says. What's really interesting, though, when they started looking at the data is if they inseminated here slightly earlier, they got female cows. And if they inseminated slightly later, they got male cows. So if they're running low on any one in particular, they could just inseminate. And it's all percentages, probabilities, but that's what the data showed them once they were able to do it. And it gave them way more than that as well. Once they hooked this all up and they went through Azure, because I'm an MVP, so I'm going to give you the Azure version. But essentially the cow wanders around and all the data goes up to the cloud, and then it comes back down to maybe the farmer's phone by the side of his bed, and it's able to tell them not only when the time to inseminate is, but also if they're having maybe a difficult birth, the cow's going to get up and wander around a bit more. They're also able to detect about 5 or 6 different diseases with a certain probability while they were doing that, without the farmer even having to get out of his bed. And then obviously you multiply this up if you're in America or something and you've got thousands of these, then that makes your data work really well for you, and the investment not all that high other than having to make a ruggedized pedometer. So that was pretty cool. So as I showed you earlier, that landscape, that IoT landscape is pretty big. But for me, the hardware options, other than the bespoke created boards that you can get, the microbit. Who's heard of a microbit? Oh, good. That's more hands than I usually get, actually. I love the microbit, actually. It's only about a tenner, but it does more than you imagine. But I'd put that at the bottom rung of this list of devices, just because of where it's placed. Next up is the Arduino. Hands up who's used or seen or heard of the Arduino. Good, good, good. And then you can get about 6 million different versions of the Arduino, and the Mega is just another one of those. Essentially, more memory, a couple more pins. And then there's a particle photon. Anyone heard of that? Nobody. Actually, these are really cool. You get a whole web interface that goes with it, so an online web IDE, a bit like the Monaco version for Microsoft. But essentially, you can do all your programming online and send all the code directly down to the device. So if you don't mind being vendor locked, it's really good. You can take those bits and bobs that are coming out of the particle and feed them into any cloud platform you like. So there's integrations out there for Azure and AWS and all of those. So that's cool. And then there's a Feather Huzzah. So this is just a slightly more non-vendor locked version of the particle photon with a bit like an ESP8266. It's got Wi-Fi built in. And then Microsoft have got into the market a little bit. They've created this MX chip board, which is essentially to try and get you to use Azure's IoT offerings like IoT hubs and stuff like that. That comes with all of the necessary security built in, though, which a lot of these before just won't have, and with enough grunt to be able to talk out to something like Azure. And then the Raspberry Pi. I'm guessing there'll be a few hands for Raspberry Pi. Cool. Can anybody tell me what the difference between the Raspberry Pi and everything I've just mentioned is?
Presumably that's x86 compatible and nothing else.
Also, sort of. This is a full PC. All the rest of them are microcontroller based. So you've got a keyboard and a mouse, the monitor and internet connection and all of those good things. So this is essentially a full, in most cases, Linux powered computer. So it can do way, way more than all of these, like, all added together pretty much. And that's generally just down to the speed of the processor and also the amount of RAM that it's got, certainly these days. And then there's people strapping FPGAs and high-speed processors to do edge processing, like doing cognitive services at the edge and stuff. I'm not going to go into great depth about any of these, but the cost at the bottom of that, so 15 quid for a microbit, actually you can get it for about a tenner. It's got stuff built in, which is why I like it. This is great for kids because it's all just in one board. Don't have to connect anything much up. I can do getting started just on the board, which is handy. So you plug it into your PC with USB. It's got a couple of buttons and some LEDs and a few ports that you can hook up to at the bottom there, and it's got Bluetooth stroke radio built into it, which is a nice little tool. You can turn those LEDs into a light sensor, which I thought was some cool science. And it's got an accelerometer and a compass built into it as well. So it packs a little punch for saying it's only a 10 or 15 quid. It's not bad. The Arduino, very similar, but I mean, if you want to buy a proper one, it's 20 quid, something like that. But if you want to buy a knockoff one, and it's an open source design, so there's heaps of them, then you can get them, 5 quid, that's probably overestimating even. They're cheap. And pretty much this is where people start with Arduino, interestingly, rather than one of the other platforms. And it's slightly different. It's, as I say, its microcontroller is a bit bigger generally, but it's a full-size USB. The board itself is bigger. Same sort of idea of pins based on there, but you've got a way to plug stuff into it now. Similar to the microbit, I didn't really mention, but you've got serial ports and things like that, and a bunch of analog inputs. You can power it separately, so if you remember my little robot arm there, it had 2 servos on it, and it would really struggle just off your PC's 3 volts to be able to power enough like that. So this gives you the facility to be able to put 12 volts in or something like that, which is nice. It actually runs off hats, or in this case shields, and you plug a shield, as it's called, an add-on board onto the top of that, and you can get Wi-Fi if you like, or many more pins of I/O, or an LCD, or anything you want really. There's millions of different of those shields. This MX chip device here, the Microsoft one, that's going up in price here now, so 35 quid for that. But that comes with like an OLED in the middle, and it's got Wi-Fi built in, and same sort of form factor as the microbit, on purpose. It's got some analog stuff, OLED. In fact, that OLED, somebody's rickrolled that already, of course, and a couple of buttons. So that's pretty cool. And moving up to Raspberry Pi 4, so 35 quid. In fact, the latest Raspberry Pi 4 comes with 2 gig of memory now for 35 quid since their birthday. The Raspberry Pi's gone to space. Has anybody heard of the AstroPi project? A couple of people. So that's Tim Peake, and there's 2 of these Raspberry Pis. I think they're 3B pluses actually, sitting up on the space station. And what they allow you to do, or allow children to do, more to the point, is write experiments that run on the space station, and they get their results back. In fact, there's something called Moonhack, which is just kicked off again now. And this is a way to try and get kids into computing by doing something which is cool, and obviously space is pretty cool. There's 2 different versions, so you can do a version of a no experiment, but it just scrolls your name and hello astronauts or whatever on it. And so sort of, 3 to 9-year-olds could happily do that. And then if you're a little bit older, then you can put yourself in for a competition to get your experiments to run on the space station, which I think is a really cool idea. That's based on this little hat, as it's called, so similar to the Arduino Shield, with a bunch of LEDs and a gyroscope and temperature sensors, humidity sensors, and that sort of stuff. So it's pretty cool. The Pi, as I say, that runs a full version of Linux, bunch of GPIO, including serial ports and bits. The Pi 4's got dual 4K outputs, which is just incredible. 4 USBs, including 2 USB 3s, Wi-Fi, gigabit Ethernet, and up to 4 gig of RAM. It's just incredible. If you want the 4 gig of RAM version, I think it's about 50 quid, but even so, for that much power, it's incredible, really. I like it. But most people see all of those different options when they start looking, and perhaps start thinking that the head's going to explode. Or maybe they think, I'm just going to dive in, but when I do dive in, when I start plugging stuff in, it's just going to explode. And so they take their new purchase and they open the drawer and they shove it in there. And in fact, most people I speak to, when I say, what have you done with it? Nothing, it's in the drawer at home. And that seems to be a common story. And mostly when I ask them the reason why, it's because I don't know how to get started, which is kind of the point of this talk. So turns out you don't actually need your hardware, even though I brought it, to get started with this at all. You can do all of it in simulators online. So we'll start with the microbit. I'll turn the slides off and we will come back and recap what we've done. So let's switch to duplicate. And you'll need to shout at me if you think it's too small, but I will be able to zoom in, so don't worry too much. So this is MakeCode, a Microsoft product. Has anybody used Scratch? Yeah. So this is very much like Scratch. So we do a new project, and those of you Scratch will recognise that same sort of idea where you drag blocks onto a visual designer. I actually really like it, and for getting started with anything, it saves having to write in a horrible language you might not want to have to write in. But on the left-hand side there, we've got a simulated microbit, and it works. So if I do something really basic and just drag an icon in there, we'll see on the left-hand side, we have an icon appearing. a bit more than that, if I drag a button press event, and we might as well have 2 of them, because we have 2 buttons, an A and a B. So you see there we've got A and B button presses because we have an A and a B button. Zoom back out again, and let's just do something basic like showing a different picture. So we can just click on little down arrows, and I mean there's nothing complicated about what I'm doing here, but it gets you started without you having to think too much about what it is you're doing. Oh, that's the same one. All those ones I had to choose. And so I can press those buttons now, and we get those icons appearing on there. And that's, I mean, that's pretty cool all on its own, but we can do slightly more advanced things. Has anybody used a servo before, or know what one is? A couple of people. So we can make servos work on here as well. And you'll see as soon as I drag this on, down the bottom left-hand corner, we've now got a servo. And it's telling me exactly where to connect it up. So this pin to there and this pin to there. I'm not entirely sure why they use those colours, because when you buy a servo, these colours that you can see down there, the yellow, red and brown, are pretty much exactly what you'll get no matter which servo you buy. You'll be able to see that it'll be those colours. So it's telling you what pin to connect exactly to where, so that's quite handy. But if I come back out of that, I'll drag this one down here and change that to 0. And if I press these buttons, then our servo moves. So you remember my little robot arm again? Well, that's the basics of that, and I've not needed to buy any hardware or worry about blowing anything up. I've just dragged a couple of things on there, and it's allowed me to do that straight away. So if you imagine you could show them anybody a robot arm working and then to be able to take them through those steps without even having to have it. And then it's amazing when people start seeing that. When ideas start springing into the head and you can play. You can have more than one servo on there if you like. Let's see, there's a couple more pins there, so I could have 3 connected to that, which is quite nice. So that's the basics of the microbit. There's a whole heap of other stuff in here as well. You can dabble with the radio, and it'll automatically drag on a couple of microbits on there automatically, and you can have them talking to each other, which is quite cool. And if you want to get more involved with the programming side of things, then we have a whole heap of different blocks you can drag in. And then if you want to take a step further, it actually gives you the JavaScript. So if you wanted to program all of that lot in JavaScript instead of in blocks, then you have that. Or if you just want to learn how JavaScript works by starting with blocks, then it's doing that conversion for you. So that's pretty powerful if you ask me. I like that. Which is why I start with it, because I've not needed to do very much to get there. I can just buy a little tiny kit and you get most of that with it. So pretty nice. So moving on to the Arduino, and actually this demo is my favourite. I always want to leave it to the end, but I like to go in an order, and that's what the order is. Has anybody heard of Tinkercad? Nobody, and that's normal. Nobody's ever heard of this, and it's cool. This is basically, it's created by a company called AutoCAD now. Autodesk, you'll have heard of Autodesk of AutoCAD, so everybody's heard of it, but no one's heard of this. And it's essentially a circuit playground. So down on the right-hand side here, we have a heap of components, and you can just drag them onto the page. So I'm going to drag a resistor, which I'll use in a minute, and an LED and a battery, and you can wire them up. So I can plug this side into one of these sides, and this side into one of those sides, and I could give them a colour if I wanted to, but I'm not going to. And I can start a simulation, and if I plugged it in the right way, then we get a light. And it's a bit more intelligent than that, because if I hover over that, I don't know if you can see it, but it's even telling me that there's too much current. And if you've ever done this before, never ever plug an LED directly into a 9-volt battery, because I don't think it'll be on for very long before it goes poof, a bit like that circuit board. So if I stop the simulation, I can delete that wire and stick a resistor in there, and then run it again, and then that's gone. That little exclamation's gone. So it even tells you if you're making mistakes, which I like. And there's a whole heap of different components you can put in there, potentiometers, buttons, capacitors. But if I scroll down to the bottom, there's an Arduino, and we can drag an entire Arduino onto the board. There it is. Whoop. So we can delete my battery entirely, and I can instead move this down so we can see what we're doing. And I can wire one end up to this, and then we can connect them up to the pins on the device. Zoom in a bit so you can see what I'm doing, and I'm going to connect that to pin 7, and then the other end to ground. So this is a really basic circuit. The idea is that you get current flowing out of one pin and it just goes down through the LED and the resistor down to another pin and hopefully lights up if everything's working correctly. And that's assuming that I've wired that up the right way around, which I think I have. But now, having dragged an Arduino on there, at the top we now get a code block. And look, this is very similar to the MakeCode environment where we have a block-driven development. Who put the hand up to say they've done Arduino development? What did you program that in?
The Arduino IDE.
Yes, and what language?
C++.
Yes. How easy is C++ to get started with? Yeah, that's pretty much the sound that people make when they try and understand how to use C++. And it's a big barrier when you go, I mean, as I said, Arduino tends to be the place where a lot of people start. And they download the IDE and they go, oh, right, yeah, I'm going to put it in the drawer.
Given 10 years earlier, I'd done a couple of years of C++, and it still took me 2 days to get stuff working.
Yeah, yeah. You can copy and paste stuff, obviously, but you've got no idea then how that's working. So instead, you can program it in this block environment. I'm going to get rid of this little piece of demo code they give you, and I'm going to drag some blocks on there. And again, shout if you can't see, but I will zoom in a second. So very similar to what we had before, we've got different categories of blocks that we can drag in there. So I've just dragged an output one in there. We can drag a control, and then we can have a little wait, and another control, and I'll change the settings on those in a minute, and another wait. Slight difference to the MakeCode environment is there's no loop. If you've done Arduino, you program in a loop. The whole thing just runs in a loop all on its own. So that's what that's kind of telling you there. This is what it's going to do. It's going to do it over and over again. So it's a little bit of a shift if you move from MakeCode to this, but not too bad. Now I connected, if I get rid of this, look, I connected my, I wish it was easier to scroll. There we are. I connected my pin to pin 7, so I need to make sure that I set my code to do that. So set pin 7. And then obviously need to make sure one of them does something that's not the other one. And low. And then if I start the simulation, assuming that I've wired everything up correctly on the board, then now we have a flashing LED. So that works quite well. So similar to the MakeCode version, it was quite easy. There wasn't much. I mean, I was spending half the time talking. That was just a couple of minutes, really. And nicely, no C involved, so handy. And I didn't blow anything up. I didn't need to worry about blowing anything up. I can just drag stuff around. It doesn't work, doesn't work. No great problem. Like the microbit, I like to show a little bit more. And drag these across a little bit so it makes it easier. Down here a little bit further, we have a servo. So very much like we showed before, we have a servo. And if you don't know what the pins do, because they're all blue on this one, I don't know why, but they are, then you can hover over them, and we can see we've got signal, power, and ground. So I mean, this is a step up from what we had to do before, because we're having to do this manually and wire it up. But circuit diagrams on the internet are 10 a penny. You can just go and find them and try wiring it up and see if it works. But you don't need to buy the kit. You just do it all on your PC without even thinking about it. So ground, I'm going to connect to, funnily enough, ground. And then power, I'm going to connect to 5 volts. And then signal, I'm going to connect over here. I don't know if you can see, but there's a tiny little squiggly bit next to a few of these pins. And that means that they're PWM pins. A servo works by sending highs and lows, and it moves depending on the distance between them. So it's pulse width modulation. That's how that's working, and this is what this code's doing. So going back to my code again. I'm doing this. Down here we have a rotate servo pin. And I'm just going to stick that in there. I connected it to pin 6. And I can do that again, rotate servo pin. And pin 6. And let's make this one 180. And then, all being well, again, if I've done it correctly, if I start my simulation, then we have a moving servo. So it's pretty good. And you can do all sorts in there. I made a motor controller, so I made a stupid little robot out of an Arduino. But I was able to put the motors on there and the motor controller and wire everything up according to a circuit diagram, make sure that I understood how it was going to work before I went and bought the kit. So it's pretty powerful. And obviously, I like the children, kids element because I can show them this sort of stuff and they can just play rather than blowing stuff up that I bought for them. But it really gets you off that blank sheet and it really does work. Removes that fear element. But, and to go back to your why have I brought all the hardware, if I go back to this make code, I don't know if anybody saw, but down at the bottom left-hand corner we have a download button. Now, interestingly, if you've got something like Windows 10, then there's an app, which makes this part even easier. But if I press that download, tell you what, let's give it a name, shall we? I'll call it Pete. Save. That's downloaded a hex file down here. And if I grab my microbit, which I wired up to be the same as that, albeit slightly more bird's nesty, but you pretty much just be able to see even at the back that I've got crocodile clips attached to the same places as the microbit there. So I've kind of just bought the bits. And in fact, if you buy like a 15 quid kit, it will come with those crocodile clips. So easy enough on your microbit, and some LEDs as well if you want them. And I've just hooked it up to a servo, and these servos are like 10 a penny, dead cheap. Not for production. If I unplug this and plug my microbit in and go to my downloads, then we have a microbit Pete hex sitting there. And if I go down here, once you plug your microbit in, it becomes a drive on your PC. So I can grab that hex, drag it onto my microbit. You won't be able to see it, but there's an LED flashing away on there to tell me that it's programming it now while it's busy copying it. And then I've got a battery pack because the microbit's not quite powerful enough, sadly, to be able to drive servos all on its own. And because I've made a bird's nest, sometimes this doesn't work first time. But there. So that was the code that I made online. I just downloaded it, programmed it straight into my microbit, and it just worked. So I didn't need to fanny around trying to figure out how that was going to work. I just dragged it on there and off it went. Likewise, if I switch back over to here, go back to my code here, we have a download button, and I can download the code for this. And that's downloaded. And if I open it, then it opens Arduino IDE. Actually, you can do Arduino programming in VS Code now, which I like. It's nice, but this works. This is saying that it needs to be in a folder, so that's all that message is, so I can OK that. It will open up the Arduino IDE for me, which it told me there was an update for, and it'll probably tell me again today. When you're ready, where are you, Arduino IDE? I didn't do the update specifically because I didn't want it to break, and now it's broke. Smashing to that one. Maybe it's because I was zoomed in. There we are. And look, it's given us C. So I've not needed to write any C. I've not even needed to remember to include that header file, that servo.h. Nearly everything you do in C, you need some form of header file. Even if you just want to do a bloody console log, you need standard out or whatever it's called. So it's given you that. It's created a variable for our servo there. And then you do some setup. So this is standard Arduino stuff if you've done it. It set that pin mode up as 7 because I told it to use pin 7 as an output. And it's told a servo to attach to pin 6. And then we're doing the writing of the LED, and then we're telling the servo to go to 0 degrees and then await, and then turn the LED back off again and go to 180 degrees and then wait, and then you can see it's in a loop. So it's just going to keep doing that. So this is a little bit more complicated, but not massively so. If I unplug my microbit, plug in my Arduino. So here's my Arduino, and I have a circuit wired up here. And all being well. The part that's a little bit more complicated is that you need to tell it what board you're using. And as I said earlier, there's about 1 million different boards, and that's not all of them actually. But an Arduino Uno is a really good place to start because pretty much all the samples are just going to work on that. So I've got that. But you also need to know what COM port to use. Now, if you've got loads of different COM ports, you might need to try and figure that out. And the easiest way is just use Device Explorer. And you can, wherever it is here. So your ports will appear in there, and if you just unplug your Arduino and plug it back in again, it'll be pretty obvious which one it is. So COM9 is mine. So all you need to do at that point is hit the upload button, and then down here it'll say it's compiling the sketch, and for the smallest program in the world, this seems to take a long time. It's still going. I don't know what it's doing, but it's finished, and it's told us that the sketch is using so much memory, not very much in fact, and now we have that same servo that some of you from the back probably can't see, but you might be able to hear it. Trust me, it's going round. So again, that didn't take me very long, and all I needed to do was just plug my servo into the same pins as I'd done on there, and you're off and running. So I like that. That makes a lot of sense to me. The LED is flashing on the board as well, just to prove that's all working. You can come up and see this in a bit. Not during David's talk though, you won't be happy with that. And so I can unplug that because otherwise it gets really annoying. So that's cool. Microbit wise, I made more silly things. This is effectively an Enigma machine. It's not an Enigma machine, obviously. But with MakeCode, you can make extensions. So you can build code that other people can use primarily. But obviously you've only got so many inputs and outputs on a microbit. You saw that little edge connector, there's not all that much there. So I made an SPI extension for MakeCode that allows me to be able to plug in IO expanders so I can get more input and output. And essentially what I've done here is I've got enough letters there for the whole alphabet and a space, and I've wired them all, it took me a long time, into these IO expanders and then back onto the microbit. But essentially, I'm not going to bother showing it because only 2 of you will be able to see it from here. But you can press the button and it says A, B, C, and you can come and see it in a bit. But what I can do is I can pick a wire out and move it to a different button for a different letter and swap it, and then you've got a letter substitution cipher. So it was just really to teach my daughter about how basic encryption works. And she was loving it then, and she was writing her own little ciphers out and sending me messages and stuff, and it was good. But again, a really good learning platform and not much involved in getting it to work. So that gives us microbit and Arduino. And if we move on, we have this. And what this is essentially, remember I said that Raspberry Pi in Space AstroPi project, and this is a simulator just for that. If you imagine kids in classrooms, they don't want to have to buy all of the kit. I mean, this metallized box and the hat and the Raspberry Pi and an SD card and a monitor and a keyboard and a mouse, it's going to add up, and if you want even one between 2 kids in a 30-kid class, then it's just too expensive. So what they've done is created this online simulator. There's a few that have come out of this project, but this is one of the best. And there's a few different projects that you can do down at the bottom. Get rid of this one. So we have sensors and rock paper pie and Flappy Hat. Of course, you know, it's got LEDs on there, so someone is going to do a Flappy Bird clone. But if I do sensors, then this allows you to be able to have a look at how all the sensors work on your Raspberry Pi. So in here, we've basically got Python code. And you can change that code. You can do what you like with it. So I can change that to a 10 if I wanted to, and actually, you know, get it to work. Oh, I probably shouldn't have done Control Z too many times. Sensors. But this actually works. So if I stop that and run it again, just so that we get the right thing, then over here we have some live bits and bobs that you can scroll around. So that's the temperature, and you can see that filling up. And this is working with the code on the left-hand side, so you can go and change that and make it do something else. There is a joystick on the real device that doesn't work, but if you use your keyboard arrow keys, then that switches to pressure. And you see we can drag the pressure up and down. And likewise, we can get humidity and make that work. And as far as I'm aware, you can even drag your, there you are, you can drag your AstroPi around and you can see the roll pitch and yaw appearing on there as well. So you can imagine the sort of experiments that you'd want to be able to do on a space station in microgravity and see what sort of readings you could get out of it at different times of day maybe. Or yeah, I like that. But simulating Raspberry Pi is hard just because it's a PC, it's a full computer. Not as easy to simulate as something which is encapsulated as a microbit or an Arduino. So that's why you get projects like this. But essentially what I've shown you so far is just the of things part of IoT, of course, and really people want to start hooking stuff up to the internet and making it do something, so to Azure or AWS if you want. So Microsoft have gone in on the game and they've made essentially a Raspberry Pi simulator here. So we have a simulated LED and a simulated pressure and temperature and humidity sensor, so a bit like the settings I was showing you on the AstroPi demo there. And over on the right hand side we have C code, which you know, I think it's C over there, but you can change that if you like, you know, add bits into it. This is live code, but essentially what it's allowing you to do is start playing with IoT hubs in Azure. Once you've got data going up to the cloud, of course, you can do pretty much anything with it. Some of the stuff, you could literally just take that temperature reading and send out a tweet if you wanted to say, you know, your house is on fire or something. But you don't need to do much to get this working. This is the demo code as it is. And what you need to do is simply create the bits, and there's help there that takes you through how to do this. I won't show you how to do it because David's going to come on in a minute and I'll get annoyed. But essentially you go and create it, follow the instructions and paste in this one line of code. And then you hit the run button, but that doesn't really show you very much. There's actually a little program that you can do that will monitor those messages. So you can download this as part of an Azure IoT SDK, and you'll get this, what's known as a Device Explorer Twin. And what that's doing is just looking at the messages in the cloud and then bringing them down to your device so you can see what's going on. And I can hit this monitor button and it will sit there listening for messages. And down here, if I hit run, and it's going to tell me that it's sending messages. Sending message, sending message. And if I flick back to my application, then we can see those messages are appearing in there. So that's going from that website up to some services you've created in Azure and then back from Azure down onto my device again. So I've not needed to buy any of that stuff to be able to start thinking about at least the cloud element. I can just leave that running there and the whole thing runs. So that just gets you off the ground for getting into Azure without having to think about buying it, plugging it in, blowing it up. Obviously, if you're doing Raspberry Pi, you've got to get Raspbian all set up and buy a bit of breadboard and start plugging stuff in. And yeah, you might not want to do that to just start learning Azure. So it's quite a good learning tool, that one. So I can cancel that. In fact, let's cancel that, clear that, and then we'll stop this from running. But of course, they don't want you using Raspberry Pi if they can help it. They want you using some of their kit. So this is an MX chip simulator. And if you remember from earlier, I told you that this is a little bit of a different device. It's got a little OLED screen on there and a couple of buttons, quite like the microbit in that you get a temperature sensor, humidity sensor and gyroscope and that sort of stuff. So it's all built in. You can see it down at the bottom down here, all those little modules. But the good thing is that this comes as it is. You just turn it on and it'll just work, but it gives you the power to be able to connect up to Azure as well. A microbit, it just can't do it because everything's encrypted and the whole communication stack is just too much for a microbit, or you know, most Arduinos as well aren't going to be able to do anything as complicated as that. So this gives you the facility to do that. So over here, in fact, I think that might have been Node over there. I was mistaken, that's Node. This is definitely C and horrible. And rightly so, you can't even edit this, but there's a GitHub where you can grab all of this code and you can move around, but you can't edit it. But like the previous example, all you need to get it to work is you just need to paste in this connection string, exactly the same connection string, if you like, that we used before. And you hit the save button, and then you can run it. And if I run it, then over here, it connects up to an IoT hub, and then it's saying, press the A button to shake. And you shake it, and then it connects to Azure, and it does a little bit more as well. It's waiting for a tweet, but if I start monitoring over here, and when that fails, I can do it again. And it's taking its time to fail. Shake. And it's telling me down here that it's sending this heartbeat. And over here, and we have a basic heartbeat that goes out. And you can send messages down to it as well. So I can call a message on the device and press send. And then down here, if it's working, then we get that message appearing. So we have two-way comms working on this one. So you can send messages up to IoT Hub, do something with them, or send a message to IoT Hub to send directly to that device. So that works out quite nicely for that. So that's the end of those demos. How are we doing for time? Just about all right? I think so. No one's saying no. Cool, that's good. Does that make sense to everybody? Yeah, nods, that's good. So going back to my slides. So we started talking about the microbit. Ooh, let's plug this back in. Otherwise, I don't want to go anywhere. And I showed you make code, which I liked. So Scratch-like block-based programming. Then the Arduino with Tinkercad, and same sort of idea. So we can circumvent the need to be able to touch that dirty C and go straight with blocks, which is nice. Then Raspberry Pi, we looked at the SenseHat emulator, which I liked. And then the Azure simulator. It really doesn't like some of my slides, maybe. And then we looked at the MX chip and that simulator. What do you think it is? It's weird, isn't it? There's a few other options. You can do this IBM Blue Mix type thing, which is like Node-RED, if anybody's used that. It's like dragging blocks, but it's a bit more complicated. You can do a lot of that IoT Hub stuff in VS Code. There's an extension you can get for that that allows you to be able to do all of the management. So that little Device Explorer twin, you can do away with that, and you can do all your development in VS Code and look at the messages and create devices and kill devices. It's pretty good, actually. That's the way they recommend you do it if you're doing anything half serious. You can do Amazon Alexa programming directly in the browser. You don't need an Alexa at all. You can do that all in there. In fact, their whole tooling's got so much better now. Their Alexa simulator and that whole programming paradigm is a lot easier. I don't think you even need lambdas anymore. They'll even do that part for you. So that's pretty good. These slides will be uploaded later, so don't worry too much about taking photos, but do, feel free. So, yeah, what do you do next? I'll go and build something. Oh, stop it, will you? So this guy's Mohit Boa, I think his name is, and he makes some really cool things. I think it's just this, because I don't think that's... Oh, it is dying. That's fine. But he makes all these wire sculptures for his IoT experiments. It's really cool stuff. I think he works for Particle, actually, which is why I tend to use them more than anything. Or you can make a silly fruit and veg piano like I did for my kids' school fete. That was a Raspberry Pi. It worked. They're good. That's my wife. Or, you know, just anything that Simone Hetcher does, he can just go and do. She's just getting over a brain tumour, and it's no wonder, is it? Or you could do that. Yeah, don't do that. So here's some links, and again, don't worry too much about these. They'll be in the slides. So all of those things I've just showed you there, they're all linked up, so you can get those if you like. Oh, I'll go back, look. Oh, it's taking a photo. People are taking photos, in fact. And then you can get the web version of MakeCode or the Windows 10 version of MakeCode, and definitely if you've got Win 10, then just get that version because it saves the copying section of that. You just press download, it goes straight on your device. You can actually get a Chrome extension that lets you do the web programming way as well if you like. And likewise for the Arduino, you can do the same. There is ways to do it, but it's just clunky, and you want to do that in any school environment, you've got no hope. So yeah, it just works that way. Tinkercad for the Arduino Uno, and then if you want to get the IDE, then you can get it from that place there. There's a web IDE as well. There it is. And then this is the plugin I mentioned for the Arduino where you can sort of program it direct rather than having to use the IDE to do it. Windows 10 IDE. If you want to know a bit more about the connected cow, you can go and watch the real version rather than the version I just stole. It's from a conference by Microsoft employees. It's just all right, some cringeworthy jokes in it, but it's worth watching. And then there's an IoT course you can go and get. I don't know if that's been closed, Virtual Academy now, then we're closing it, but they'll link to the MS Docs version of that. And then if you want to get in touch with me, then there's a million different ways to do it, but Twitter is generally going to be the best way to do that. Tonight's slides will be on that link, so if you want to take a photo of anything, you can take a photo of that, and then once I've finished uploading it, then you can download it from there. Done. Any questions? It took me ages to do this GIF, by the way. Go ahead.
What kind of age group do you teach on?
When I started with my daughter, she was 4.5 with the microbit, and that little LED thing on there, you can do little games where you can chase things around on a little dot, chasing another dot and stuff like that. Did Scratch even on the Raspberry Pi. Hardest part of that was that she said, "Daddy, Daddy, Daddy, can we do something?" I go, "Yeah, all right." But with the Raspberry Pi, it's not just a case of, yeah, all right, unless it's all on and ready, start it all up and then get scanned. Of course, this was Pi 2 and everything was slow on there, and she was bored and watching Moana at that point. So, those ones, specifically the microbit, you can do from any age. I made a treasure hunt. So these two microbits can talk to each other, and in fact, multiple microbits can talk to each other. But you get a radio strength reading from it, so you can tell how close you are to another microbit. So I was able to scatter microbits around, and she could walk around with them and try and find the other microbits, and it would beep like a metal detector when she was close to one, and she loved that. And anything like that, just to get people involved, never mind children. But the look on kids' faces when they start doing this sort of stuff, and it's amazing how ingenious they are at just not doing what you expect them to do, but some cool stuff anyway. Anything else?
Yeah, so obviously you managed to extract a bunch of C code from I forget which website it was.
Yeah, Tinkercad.
Can you do the inverse?
No, I don't think so.
Because I had hell when I was playing with a lot of ESP32 as a fruit feathers, God, words.
Not enough beer.
Where the debug cycle is quite painful once you get onto the devices.
Yeah. However, there's an extension for VS Code now that will let you debug it.
So is that VS Micro?
Can't remember.
I ended up buying something for Visual Studio Full Fat, actually.
Right, yeah, there's one of those. Yeah, that might be it. Yeah.
I found it quite a painful experience, and I was desperately hoping there was an emulator somewhere, and they just don't seem to exist.
No, JTAG is how you do it. So you have to buy some kit. So it's another board that you plug in, and that is awkward, and that is one of the biggest problems. Yeah, and this is dead good, but you can just do it in. I don't think you can do breakpoints in there, sadly, but I think there's a way to turn this into C. Just look at it as C in there as well. I forget how you do it. But yeah, this is dead good. I love this. Definitely my favourite demo. That one there. Oh, Will. Any other questions? No? Good. Thank you very much.